Hello everyone and welcome back to the channel. If you're a college student or someone who wants to build a strong programming foundation before learning data structures and algorithms, then this masterclass is exactly for you. Today, we're starting from absolute zero. It does not matter if you have never written a single line of code before. It does not matter if programming feels confusing right now. By the end of this masterclass series, you will have a solid foundation in C++, and most importantly, you will understand why every DSA topic depends on the concepts we are going to learn. Now, let me tell you something that many students realize too late. Most students directly jump into DSA because everyone says DSA is important for placements. Then they get stuck. Why? Because they don't understand variables properly, they don't understand functions, they don't understand arrays, and even they don't understand memory. And when they read linked list, trees, graphs, or even dynamic programming, everything starts feeling difficult. That is why we are doing things the correct way. First foundation, then DSA. By the end of this series, you will be ready to start learning arrays, strings, STL, time complexity, recursion, and eventually complete data structures and algorithms. Let's begin. This is the roadmap of this video. If you complete all three parts carefully, your foundation will be very strong. Many students ask this question: why should I learn C++ when Python exists? It's a valid question. Python is easier to write, but C++ teaches you what is happening behind the scenes. It teaches you how memory works, how data is stored. It teaches you performance optimization and also how computers actually execute programs. And that is exactly why C++ is still one of the most popular languages for competitive programming, coding interviews, placement preparation, problem solving, and system programming. When you learn C++, learning other programming languages becomes much easier. So think of C++ as your foundation language. Before writing code, let's understand something interesting. Have you ever wondered what happens when you click the run button? Most students don't. They simply write code and press run. But understanding this process makes you a better programmer. When you write a C++ program, the computer cannot directly understand it. Computers understand only machine language. So your code must be translated. This translation is done by a compiler. The process looks like this: your code, compiler, machine code, and then output. Simple. That is why C++ is called a compiled language. Now let's write our first program. So here I have created one file with the file extension .cpp, which is for the C++ file. At first I will write hash include iostream. This includes the input-output stream library. Without it, we cannot use input and output functions. Next line is using namespace std. This allows us to use standard library tools without repeatedly writing std colon colon. We'll see it further. And in large software projects, many developers avoid using namespace std because it can create naming conflicts. But for learning and competitive programming, it is perfectly fine. So next thing to be written is the main class. We'll start it with int main, then parentheses, then these curly braces. Every C++ program starts execution from the main function. Think of main as the front door of your program. The operating system enters through this door. Next will be cout, which is used for displaying output, and we can print here and for smart solutions like this. And at last we'll put a semicolon here. So this is the program that we have written. And for example, if we wouldn't have written this using namespace std, then here itself we had to write std colon colon. And if we want to print multiple things, then multiple times we had to write here std colon colon. So instead of that, we are using this line. So let us run this and see. So as you can see, InfoSmart solutions got printed. So congratulations, you have written your first C++ program. Now let's understand memory. So before learning variables, we need to understand this. Imagine a huge apartment building. Each apartment has a unique number. Computer memory works similarly. It consists of many locations. Each location has an address. Whenever we create a variable, memory is allocated to store that value. Think of it as renting a room in memory. Now let's see how variables work. A variable is simply a named storage location. So, for example, let's just remove this. Instead of this, we'll write int age is equal to 20. Just forget about int right now and focus on age. So, this age is a variable name. This 20 is a value. The computer reserves memory and stores the value. Let's see more examples. If we write double CGP is equal to something 9.91, then this CGP is a variable and this 9.91 is its value. Forget double right now, it's the data type that we will read. Next, if we write grade like this, so again here grade is the variable name and A is its value. So each variable stores a different kind of information here, as you can see, and that brings us to data type. So different kinds of information requires different storage. So this age we stored it as an integer value, that's why we have written here int. CGP as a decimal number. So here you can see it's double, and here grade is a character, and so we use the char. Next, other thing can be bool. So bool place is equal to false like this. So here place is, or we can even write place, whatever. So this is a variable name. False, this is the value, and bool, this is the data type. Boolean is used when we need to store true or false values. So these are very useful in conditions and decision making. Now, sometimes we want to know how much memory a data type consumes. So for that, we'll use size of. So if we see out, this is for print that we already read, and then size of, for example, int. If we see, so this displays the memory consumed by int, which is 4. The exact size can vary depending on platform and compiler. So now there's a mini challenge. Just pause the video and create 3 variables: your age, your CGPA, your grade, and print all 3 values. Try it yourself before moving ahead. Alright, so until now our programs have been using fixed values, but real programmers take input from users. Suppose I want the user to enter age. How do I do that? So for that we'll use cin. So this is the thing cin which we will be using. Now let us say we want to take input from the user, the age. So first we'll just create this variable int age. We haven't assigned any value from it because we'll take that from the user. Now we'll print here enter your age. Next thing is we'll take the input, so cn, and just see the angular brackets you're using, and then age, because age is the name of the variable which we made here. We already give its data type as int because we want the age to be an integer value. After this we can print the age. So we can write here your age is, and then here itself we can put these brackets again and we'll write the name of the variable age. Let's see the result. So cout will first print the message, enter your age, right? And now it's asking for the age. So let's say 20. And then it printed your age is 20. So this was the input taken by the user, uh, input given by the user, and this is the output. Your age is 20, which we wrote here to be displayed on the screen. Now let's build a small program. In this, first we'll take two numbers as input and display their sum. So we have to make two variables, A and B, because we want to take input two numbers. So that means two variables. Now first we'll input the first variable. So we'll write enter first number, C in, and here we'll write A. Then next will be enter second number, then C in B. So we have taken input the values of A and B. Next thing is to calculate its sum. So we have to print the sum. And that's why we'll say here sum is equal to then this. And here we can write A plus B. We would have done like this. We would have made another variable sum int sum is equal to A plus B, and then we're writing a sum, or instead we can directly write here A plus B. So this is the beginning of problem solving. Every software application works using the same idea. Take input, process input, display output. So it's asking for the number. 10 plus 2 is 12, and we have successfully printed it. Next thing is operators. So let's learn how computers perform calculations. So operators are symbols that perform operations, and there are three important categories. Like first one is arithmetic, second is relational, and third is logical, as you can see on the screen. Arithmetic includes this plus, minus, multiply, divide, and this modulus operator, which gives us the remainder. Then relational is used for comparisons. Like here, it's equal to means if two things we have to be two things have to be compared. Not equal to is when they're not equal, then we'll get the value true, and then this greater than, less than, greater than, equal to, less than, equal to, and so on like this. Logical is for combining conditions, like double, ampersand is and, this is for or, and this is for not equal. So let us see. If we say int a is equal to 10 and int b is equal to 20, and here we print a plus b. We already printed is, but still, let us try again once. So as you can see here, we got 30. Now if we say to give us the remainder, here we got the remainder as 10. Likewise, we can do several operations from it. Now suppose, let's see a practical example. If we have a company and it requires CGPA greater than equal to 7 and percentage greater than equal to 65, then how do we write it? So first we'll make a boolean variable. So we have written here the data type as bool, then the name of the variable which is eligible, then as I said, CGPA greater than equal to 7. So CGPA greater than equal to 7 like this. And we want the percentage also to be greater than 65. So we have two conditions here and we have to combine both with the AND operator. So for that we'll write 2 ampersand and then percentage is greater than 65 like this. So here the both conditions, if they are true, then eligible would get a boolean value of true. If even one of the condition is false, then eligible will be false. Now let's get this placement eligibility checker. So here we have taken two variables CGP and percentage that both have the data type double, that is for the decimal values. Now we have to take the input from the user. So we'll write enter CGPA, and in the next line we're taking the input CGPA because this is the name of our variable we have taken here. Similarly, we'll ask it for the percentage. Then at last we'll just print the value of eligible. So first we just declared the variables, the data types. Then here we have printed enter CGPA, taken CGPA from the user, then enter percentage, taken percentage, and then we have defined this eligible which has the bool value, and at last we are printing this eligible. Uh, why is it showing error? Let us see. So let's say our CGP is 9 and our percentage is 50. Then you can see we got 0 because it's a false. False is 0 and true is 1. So if we say here CGPA to be 8 and percentage is 70, then we got a 1. So it was not an error, it was just not updated, not saved. Okay. So this is the end of part 1, and we have covered here why C++, how programs run, compilation, variables, memory basics, data types, input output, operators. These concepts may look simple, but trust me, everything in DSA is built on top of these foundations. Now let's start with part 2. Now we are moving into the section where actual problem solving begins. This is the point where most students stop just writing code and start thinking like programmers. Imagine you are building a placement portal. A student with CGPA above 7 is eligible. A student below 7 is not eligible. Now the program must make a decision. How do we teach a computer to make decisions? Using conditional statements. The most common conditional statement is if. For example, if here I write int age is 20, and then if I say if age is greater than equal to 18, then it will have to print eligible to vote. So here the condition is checked. If age is greater than equal to 18, this condition will be checked. If it's true, then it will execute the lines written in these curly braces. Otherwise, it won't go inside these curly braces. So if it is true, this block will be executed, and if it is false, this block will be skipped. Simple. Suppose we want both possibilities. If marks is greater than 40, then we need to pass, otherwise we need to fail. So this is another example. So we'll write here int marks is equal to 35. Then if marks is greater than equal to 40, then we will print here pass. Else, because we want if the marks is not greater than 40 or not equal to 40, then also something to be printed. So else includes all the conditions when this first if block, which is this, is false. Here we will print fail. So here pass and fail. Let's try this. So it's at failed because the marks we gave was 35. If we say it's 45, then it showed pass. So we got only one, either pass or fail, but not both, of course. Now the next is if we have several property possibilities. So if marks, let it be 45 only, and we say if marks greater than equal to 90, then we have a grade of A plus. Else if marks is greater than equal to 80, then we have grade A. Else if marks is greater than equal to 70, then grade B. And at last we'll put else. Else means if all the above conditions are false, this marks is neither greater than equal to 90, neither greater than equal to 80, neither greater than equal to 70. So if all the three conditions will be false, then we'll get this else, and here you're writing that the student got grade C. Let's run this, and we gave the marks as 45, so it should go in this else, and yeah, we got grade C. So the structure is very common in real world software. Now a practice problem. Create a number checker. A number from the user should be the input, and output should be positive, negative, or 0. I hope you paused the video and tried it. Now I will be writing the solution. So first we'll make one variable as num. We'll input that variable, and before taking the input we have to print here, enter the number. Next we'll check if number is greater than 0. Then we'll print it positive. Else if number is less than 0, then we will print it negative. And the last will be else. It will be 0, because if the number is neither positive nor negative, then the number will be 0. So let us try run this. Let us say the number is 0, then we got 0. If we would have said 3, it's positive, minus 3, then it's negative. Now the next thing is switch statement. When there are many fixed options, switch is often cleaner. Let us take another example. If For example, we have day as 3, and we want to print Monday if it's 1, Tuesday if it's 2, Wednesday if it's 3, and so on like this. So we'll simply use switch case. So here we'll write switch, then in parentheses the name of that variable, which is day. Now inside the curly braces we'll write case 1. And what should be done in case 1? It should print that it's Monday. And the second case, case 2, in this we have to print Tuesday. Then next is case 3. This should be closed at the last line here. Indentation is not required in this language, but just to make it clearly visible and standing everything, I'm just giving a tab space. So case 3 will be Wednesday, and so on like that. We can write till 7. So let us write till here only right now. If we see case 1, it will print Monday. Case 2, then Tuesday. But here we need a break statement as well, because if the first statement is true, that is case 1, it will be Monday, and if we haven't put this break, then it will print all Monday, Tuesday, and Wednesday, and whatever we will be writing further. So it will execute all the conditions. If, for example, case 2 is true and we haven't written break, then it will print from Tuesday, Wednesday, and all below it. And that's why this break is required to be written, so that if one of the condition is true, then it just executes that particular condition and breaks. Breaks is just to exit from that loop. So you can see Wednesday is printed because we had taken here a day as 3. We can even write default here. So default, and in this will print invalid. So default case executes only if none of the other cases match the value being tested. So if we run this, you can, okay, it's running. You can see we got Wednesday again. Now if we say the day is 5, then let's see what happens. We got invalid because none of the case matches, so it just went in default, and whatever written inside default was executed. Now next thing we'll learn is loops. So suppose I asked you to print hello 100 times. You could have written cout hello 100 times, but that would be ridiculous. Instead, we use loops. So loops allows us to repeat tasks efficiently. Most common loop is the for loop. What is the syntax for the for loop is, first we'll write the initialization, then we'll put a semicolon, then we write the condition and then update. And we put curly braces here. Inside this we write our code. So let us say we need to print the number from 1 to 5. So our initialization will make one variable with, let's say, integer data type. So we'll write int is equal to 1 because we want it to print from 1 to 5. So first we have taken the variable value as 1. Then the condition. So we want it to be till 5. So I is less than equal to 5, because if we want to print all numbers from 1 to 5, then you can see what's common in all of them. Then they start from 1 and they go till 5. So all the numbers are less than or equal to 5. So we have put this condition here. Next is update. So what we have to do is we have to go from 1, then 2, 3, 4, 5. So we are just adding 1 in the number. That's why we write here I plus plus. And here what do we have to print is the value of I. So that is C out I. Now let's print, and if we see, we can see the result. It is printed 1, 2, 3, 4, 5, but it's printed together. So for printing it in different lines, what we have to do is we can just write here end L. So it moves the cursor to the next line, and so now you can see every number in different lines 1, 2, 3, 4, 5. So first one is the initialization, that is int I is equal to 1. Then we gave the condition I is less than equal to 5, and then we updated it I plus plus. What is I plus plus? So I plus plus simply means I is equal to I plus 1. This is what is meant by I plus plus. For example, if we say I minus minus, so it means I is equal to I minus 1, like this. So what happens here is, how does this loop work? First, we set that I should be 1. So here, let us write I is equal to 1. Then it checks the condition I is less than equal to 5. So this is satisfied. So that condition is true. So it will just go here. It will print I. So we got 1 printed. Now our cursor moved to the next line. So let us say write it here. So first we have written 1, then next line, and then again it went here, then I plus plus is the condition. So I is equal to 2. Then it takes this condition, this is true. Now it prints this. So 2, and then next line again. Now again it went here, I is equal to 3. Then it checks I is less than or equal to 5. Is it true? Yes, it's true. Then I plus then it goes to here. 3 is printed. Then again next line. Like this it happens, and when we get 5, then again it's true. I is 5 and it's true. Then it prints 5. It comes to the next line. Then I becomes 3 because 5 plus 1 is I becomes 6 because 5 plus 1 is 6. So then it checks this condition and it's false. I is not less than equal to 5. So it does not execute this further and it stops. So this is how we got this 1 to 5 number printed. Now if we want to print numbers from 1 to 100, just try it on. Just the condition is to be changed, rest all things will be the same. Next is while loop. While loops are useful when we do not know the exact number of iterations. For example, if we take int energy to be 5, then we say while energy is greater than 0. So here what we did is, first we wrote while, then inside the parenthesis we gave the condition energy is greater than 0. Here we haven't written any condition and we haven't updated it. So what we'll do is, how we'll update it. So first inside this while we'll write the thing to be executed. So for example, if we want to print coding, for example, we print this, and we'll move to the next line as well. Now this energy, we'll update it here, minus minus. If we write this, so basically the value of energy will be decreased by 1 in this loop every time. And this loop continues until the condition becomes false. So while energy is greater than 0, let's start here, like energy is equal to 5. So energy is 5, right? So coding will be printed. Okay. Then energy minus minus. So we'll go here again. Energy minus minus means energy is 4. Energy is 4. 4 is greater than 0. It's true. Then we get back here to the print statement coding. So coding is printed. Like this it goes on, and when energy is 1, then again it prints coding. Then it says energy minus minus, so energy is now 0, and this condition is false. Now this condition being false, these statements will not be executed and the loop stops here. So let's see. We got coding to be printed 5 times. Now let's see the do while loop. So let us take a number as 5, and in do while we need to make first the do thing. So do, and inside these curly braces we'll write, for example, to print num, and in while we'll say num is less than 3. So even though the condition is false, the loop executes once. This is a special property of do while loop. Let us see. So we got this 5 printed here. What happened is first number is 5. Then this loop is executed first, like this C out 5. So 5 is printed. Now we'll check the condition if this condition is true or false. In this case, this condition is false. So the program breaks here. So this do while is when at least once the loop should execute. So this do is executed first, and then we check the condition in this. This is the main difference. Now the next thing is break and continue. So these two keywords are extremely important. Break is to stop the loop completely. Let us write example of a for loop. So for int I is 0, I is less than equal to 10, I plus plus this, and inside this let's put a condition. If I is equal to 5, then break. Otherwise, here we have to print. So this we have written, like this is the for loop that will go from 0 to 10. Inside this we'll check the condition. If I is 5, then break, otherwise it will keep printing. Let us first see the result. So here we got the output as 0, 1, 2, 3, 4. If you see, we gave it to print from 0 to 10, but it only printed till 4. This is because here we have written break. So when I is 5, a break means that it just stopped the loop completely. So this was our loop, our for loop was this. So it got out from the for loop, and that's why no other number after 5 or even 5 was printed. Now if instead of break we write here continue, then what happens? Let's see. So as you can see here, we got from 0 till 10, but we didn't get 5. What it means is, if I is 5, then continue means it skips that iteration. It just went to this for loop again, and it did not executed this line of code. So continue is to skip the current iteration, and loop is to stop the loop completely. Sorry, break is to stop the loop completely. Now let's solve a practice problem. Just to find the sum of first n natural numbers. So for that, first we'll make one variable of integer data type. Then we'll take input of that variable, and before this we'll print enter number. As we need to sum a natural number, so we can do it like 1 plus 2 plus 3 like this, so on till n. Like writing it like this will not be good. So what we have to do is, if you realize that we have to print one by one, sorry, we have to sum one by one, so we'll use the for loop here. So for using the for loop, for we'll write here for int I is equal to 0, I is less than equal to n, then I plus plus. So it basically means that the loop is going from 0 to n. Its natural number should go from 1 actually, but 0 is also fine because anything added to 0 will be the number itself. So here we have given the condition that the loop will go till n only because we want to find the sum of first and natural numbers. Then we'll make one another variable here named as sum. What we'll do is we'll just add that number to sum. Sum is equal to sum plus I. So basically I will be 1, then in sum that 1 will be added when I is 2, then this value of sum gets updated. Sum will be 1 plus 2 which is 3, then when I will be 3 it will be 3 plus 3 which is 6, and so on like this. So at last, after the completion of this loop, we'll just print sum. It got some error. Let's just run this again. Yeah, it's running now. So if I say 3, then you can see we got 6, which is the correct answer. If I say 4, then we got 10. So the next thing is functions. So for this, imagine building a huge application, thousands of lines of code, putting everything inside main would become impossible to manage. That is why we use functions. A function is a usable block of code. If you write here void greet, and this is greet is the name of the function that we have given, then we have put parentheses, and void means it will not return any value. We'll read about it further. So inside this, let us say that it has to print InfoSmart. Now inside main, we're calling the function. The name of the function was greet, so we are calling it right this. And we will run this. It says that we have some error in the program. Okay, we mistakenly have written it inside main. So first we have to write this function, and then we have written our main function. So here you can see InfoSmart is printed. So what we did is we just made one function greet. We called that function in our main class, and then whatever written inside that function, which was see out InfoSmart, that is to display InfoSmart on the console, that was executed. Now we wrote here to print, so that's why we have written here void. We would have written it to return some value, like we write here return 0 like this something. Then we'll just change this void. We'll not write void, but we'll write the data type of the thing we are returning. When we will be practicing further programs, then you will be able to understand more. Now let us see function with parameters. So if we say a string name and we say it to print hello and here name like this. So we have given this parameter, its data type is string and the name of that variable is name. Here we can give the value of it, like we can write Ria. If we see the output here, we should get hello Ria. Yeah, so we got hello Ria. Now function with return value. So as I said, that will write here return. For example, if we take two numbers, so a plus b, and if we have two numbers, then here we have to write int a comma int b. And as a, it is integer plus integer, so the value of this, the data type will be integer, and that's why we have to write here int. Now here we will be giving the values of a and b. So let's say 10 and 12. Now if we run this, we should get 10 plus 12, which is 22. Oh, okay. We returned the value to the function, but we didn't actually print it. So see out this. So we got 10 plus 12, which is 22. Next thing is scope. Scope defines where a variable can be accessed. For example, if we write void test and inside this we'll write int x is 10 like this. So this means that the variable x exists only inside the function. If we make one main class and inside this we try to print the value of x, then we'll get an error because this is called the local scope. So you can see we got an error here because this x was defined inside this test function and we're calling it inside another main function. Next thing is pass by value. So it was very important for interviews. It is basically like if we make one function void increase and inside this we give this index and we say it to increase the value of x by 1. This is what it should execute when increase function is being called. Now if we call this function inside a class, let's say we made here num 5, int num is equal to 5, and now inside this we call increase num, and then we just print the value of the variable num. Now let's see what happens. We got the value as 5 but not as 6. Why? Because a copy was sent, the original remained unchanged. What is meant by the copy is sent? So this num is 5, and when we send this num in increase, this x is not exactly the same as num. This x just got the value, the same value as what num was having. So x is equal to 5. So x got increased by 1, okay, but here we printed num and so nothing happened. And that's why we say a copy was sent, the original remained unchanged because we got the same value of num at last. So if we want the both of x and num, both the variables to be same, then we can just write a ampersand. And now when we execute this, we should get 6 as our answer, and yeah, we got. Because now the original variable changes because the copy was not sent. Instead, num and x, they both are the same variables. So if x value got changed, then num value is also changed. Now the next thing is arrays. This is one of the most important topics before DSA because an array stores multiple values of the same type. Example, if we make first main class and then inside this we'll write array like this. So first we are defining the data types of the elements. Then this is the name of the array. Then inside the square brackets we just defined the size of that array, which is 5. Size is 10, 20, 30, 40, 50, like this we have defined. We kept 5 elements because we defined here the size to be 5. So here index 0 will be 10, then index 1 will be 20, and so on like this. So the array indexing starts from 0. Now if we want to traverse in this array, what we can do is we can write here for int I is 0, I is less than equal to 5, uh no, it will be I less than 5, then I plus plus, and then we'll print this. So array, and in square brackets writing I means array 0, array 1, array 2, this as the loop goes on. So array 0 means in this array the one with 0th index, so element is with 0th index is 10, so like this. Now when this is array 1, it means 20. Array with index 2, which means 30, and this is with index 4, this is with index 5. So if we say we got all the elements because we did write here end line or give it a space, and that's why it's printed in a continuous manner. But anyway, it goes from I equals to 0 till I is less than 5 because this one is 0, then 1, then 2, then 3, and then this finally this is 4. Next is to find the sum of the array. So for that we can make int sum is 0, sum is a variable, and here we can just say it sum plus equal to this. Sum plus equal to means sum is equal to sum plus this. So it's a short way of writing this. If we sum this, then answer should be 150. Oh, we forgot to print the sum. So after the for loop is over, we need to print the sum. So we got 150 here. Next thing is to find the maximum element. So for that, we can make a variable here max, which we can give the value as this 10. Like whatever is in the first, whatever the first element is, or the element with 0th index of the array, we just equate it to max. You have to remove the sum, and also we'll print max at the last. So for finding the maximum value, what algorithm will use? So first we have taken this 10, this max is given this value, and then we'll compare this 10 with the next index element, which is 20. If 20 is greater than 10, then the value inside this max should be this 20. And then we'll see 20 and 30. So 30 is greater than 20. So max should be equal to 30. So basically we are just first comparing the first element, the second element, then second, third element, then third, fourth. Sorry, we are first comparing the first and the second element, and then whatever bigger number from it we have, whatever max number we have, then we are comparing it with the next element, and then whatever is maximum out of max and 30, we are comparing that number with 40 and so on like this. So let us write, then it will be more clear. So if the element is greater than maximum, then maximum should be equal to that element. Basically, we need to find the maximum element. So if any other element is greater than the maximum, then maximum should have that value. Let's see the output. So we got 50 because 50 was the last element here. Let's say if here it was 100 and then we see this. Okay, so, we haven't changed the size. Let us say let's remove this element because then we had to change here also. Here we got 100. 100 is the largest element. Now next is linear search. In linear search, like if we are given an array and we need to find one target element. Okay, now we have to make the array again. Shouldn't have removed that. So let's say 10, 30, 40, 50, 29 like this. And to find that particular element, we need to traverse through the array again. It is of 5 size. Inside this, we'll compare it. So what target element we have to take, that also we have to define. So int target is equal to 40, let's say. And inside this, we'll write if the particular element of the array is equal to target, then we'll simply print found. And we can even print the index of the element is, and the index will be I. So let us see. So found and index of the element is 2 because 0, 1, 2. So 40 was at second index and that's why it has printed 2. Basically, when I is 0, it compares this with target. Target is 40. So it compares if 40 and 10 are equal. So they're not equal. Then it again went to here. And I plus plus. So I is 1. Then it compared again. And like this, it moves on till we reach the target. Next thing is strings. So strings store text. So let us take an example of string. To say string name is InfoSmart. So by now you have seen that string is enclosed in double quotes. Now we can directly print this. See out name. Unlike character, strings can store multiple characters. So character like can store only one character. Char can store only one character, and string can store multiple characters. So now taking string input, so we can say string name, and here we say to enter name. Next we say cn name. We run this. Here if I enter info smart. Oh, okay. I haven't printed here anything. So your name is, and here name. So now let's see. So if I enter here InfoSmart, you can see your name is InfoSmart. But if I enter here InfoSmart Solutions, then you can see it again just gave me InfoSmart. It does not consider solutions because we gave a gap in between both of the words. So for that, what we can do is we can use get line. So instead of this, we can write here get line. Inside this, we'll write C in name. Now, when we run this, InfoSmart Solutions. So you can see we got the full name InfoSmart Solutions instead, in spite of the fact that we gave a space in between. So this is the use of this get line. Now the another thing is string length. So we can print the length of the string. So name dot length like this. Let's execute this. Let us say info. Then we got it as 4 because we haven't given here and L, so that's why it's coming in the same line. So by this we can find the length of the string. Next thing is a string traversal. So we can traverse through the elements of a string, and for that let's just remove this and write this right here. String name is equal to Amita, and inside this write for int I is 0, I is less than. So here we give the length of that string. So name dot length and I plus plus. And here we'll say name I. Just like in array, we were traversing it through each element. Here we're traversing through each alphabet of the name or each character of that particular string. Okay, so we haven't written yet name and L, so it will come together. So better we write here and then we'll execute. So you can see AMITA. So it's all coming in different lines. So we can access each character or each thing written inside that string one by one using this for loop. Now the next practice problem is to count the variables. So for that we make here a string str, then get line C in str. So we're taking input from the user and we'll use the for loop in a different way now. We'll say character ch in str. What this means is it will traverse to each character in str. So instead of writing it like int I is 0 and then the condition, then the update, we just set it to directly access all the elements of that particular or all the characters of that particular string one by one. Now inside this we'll check, we need to count the vowels, right? So inside this we'll check if each character of that particular string is A or E or I, O, U like this. So we'll write the condition here if ch is equal to A. Now or, so or means this. Then ch is equal to B. If you notice, we are not putting double quotes here, we are putting single quotes because this is the character. We are comparing a particular character. So it shouldn't be B, it should be E. So like this, we can write it for all the vowels. And inside this, we'll say if there are among A, E, I, O, U, then we'll increase the count by 1. Here we are assuming that the entered string is in lowercase. If it's in uppercase, we can do one of the thing. We can either write capital A, capital E, and that also by putting more or operators, or we can convert that string which is input by the user to lowercase and then we'll can execute. But for now, we're just assuming that the string input by the user is in lowercase. After the completion of the for loop, we'll print number of vowels count and here and L. Let us see. So here we have to input, let us say, smart solutions, and we got the number of vowels as 7 here. So this is the end of part 2. We covered many things: conditions, switch, loop, break, continue, function, scope, pass by value, pass by reference, arrays, and strings in basics. Now let's move on to part 3. Now we are entering the topics that separate complete beginners from serious programmers. Before learning pointers, let's understand references. A reference is simply another name for an existing variable. Think of it like having two names for the same person. So let us code here. So if we say int marks is 90 and we make another like ampersand ref is equal to marks. We both now both variables refer to the same memory location. Let us see how. If this one is marks and we write NL and this one is ref, we write here NL. If we see result, we got 90. If we say that rf is equal to 100 and we print this again, so we got 100 here. Why? Because ref is not a copy, it is simply another name for the same variable. So why are they important? To understand that, if we make an array, let's say it has 1 lakh elements, then it's a huge array. Passing this array by value copies everything. That wastes money and time. Instead, we pass by reference. This becomes extremely important in DSA, especially when working with arrays, strings, vectors, trees, and graphs. Now, let's discuss memory. Imagine your computer memory as a big city. Every house has an address. Similarly, every variable in memory has an address. Example, if we say int age is equal to 20, then to see the memory address, what we can do is we can just print ampersand age like this. So this ampersand gives the address. So here you got this address. The exact value will differ on every system. The important thing is understanding that variables live somewhere in memory. Next, what is a pointer? A pointer is a variable that stores an address. So like this, age is a variable that stores 20 and we make here a pointer for that int, and this is our ptr. Ptr is just a name we have given to the pointer, then ampersand age. So this pointer stores the address of age. This is the entire idea behind pointers. A pointer just store addresses. So like when we take int age is equal to 20, then the address is 1000 and value is 20. We're just assuming that address is 1000, can be anything. It will be 0 cross 16 into something. And when we say that this int pointer is equal to ampersand age, then our variable is pointer and the value stored is 1000. So this does not store the value 20, but it stored this address, stored this address and not the value. And that's why the pointer just stored the addresses and not the actual value. Now next is tree referencing. So in this, if we have int age is equal to 20, then we have made this pointer, and now if we first print this pointer and we also print it like this. So let's see what happens. And it has print the address. So here you can see it has printed the address, but actually there's no line gap, and that's why it printed the value in the same line. So now you can see first this PTR, the addresses printed, and then using the star operator, which is called the dereference operator, we printed the value of that. So we got 20. So it simply means that go to that address and fetch the value. Next, let us just make a small program. For example, if we say that int num is 50, and then we say make a pointer and just give the address, the num to be stored in this. Now, if we print num, which is actually what the value, and then similarly, mm, let us just copy this. Here we will print the address. Here we will be printing the pointer value, and in this dereferenced value. It will be ampersand num, this will be ptr, and this will be star ptr. So first we have printed the value, which is exactly this 50, then we have printed the address. So we have given ampersand num, then we have printed the pointer, which will again give the address, and this using the dereference operator will get the value. So you can see we got this. Now next is stack and heap memory. So now there are two memory areas we need to know. First, stack, that automatically managed memory. For example, if we say int x is 10, then it is stored on stack, created automatically, and is also destroyed automatically. Second is heap. it is a manually managed memory. So if for creating a heap, we use new, delete these keywords. New is for creating and delete is for destroying. So let us see if we create a pointer and we just say new int like this. So this creates memory on the heap. Now when we say that the value of this pointer is 100, and if we print this, so we got 100 as the value. Now next is memory leaks. Like we have written this, but we haven't, but we forgot to delete it later. Then the allocated memory remains unavailable to the program until it ends. This is called a memory leak. So it's always clean allocated memory and it should delete it like this. Delete ptr, then ptr equals to null ptr. Like this, we can simply delete that. Now introduction to oops. Oh, this is one of the most important topics in college exams. And OOP is a way of organizing code using real world concepts. So instead of thinking only about functions, we think about objects. Classes versus objects. So if you imagine a blueprint of a house, the blueprint has rooms, doors, windows like this. It is not an actual house. Similarly, a class is a blueprint, an object is a real thing created from that blueprint. Let's make a class here. So first we'll write here class, then the name of that class. So let us say student, and inside curly braces will start. So let us make it public. So we'll write public, then a colon. Inside this, let us create two variables. One string with name and another maybe integer marks like this. So this is a blueprint. It does not have a data of an actual student. So now let's create objects. So for that, let us create our main class here. And inside this, we'll create S1 of student. So we'll write here student, then S1 like this. Then as we have written here name and marks, so we will say here S1 dot name is equal to maybe Read, and then S1 dot marks is equal to 100 like this. So basically we're assigning values to name and marks of a particular student named as one. And then we can even print this. So see out S1 dot name and see out S1 dot marks. So we are printing this. And here it's a class, so yeah, given a semicolon there. It's showing some error. Let us see. Oh, yeah. So here I already created this main. That's the problem. Like we need only one main inside this. That's why that error was coming. And here we can see read and 100. So we made one student S1 of the student class, and then we gave the value to its name and marks. Now the next thing is constructor. Suppose every time we create an object, we want initial values. So a constructor has the same name as the class and it has no return type, it runs automatically. So here we'll make the constructor, and as I said that it has the same name, so we'll write your student, and inside this we'll say name is equal to unknown and marks is equal to 0, like this. And now let us remove this one, and we have s1 dot name and s1 dot marks. This has to be displayed on the screen. When we run this, we should get the default values we give, that is unknown and 0. Yeah, we got this. So it's basically a constructor named student, and we assign the values to name and marks. So when we created this object s1 of this student class, then itself the name and marks are being assigned this value which was given in the constructor of that function. Now next is parameterized constructor. So in this we'll say string n and int m, and we'll say that name is equal to n and marks is m. And when we are creating the student here, we have to give the values of this n and m. So n is name and m is marks. So read and marks 100, like this. So automatically the name is given the value read and marks as 100. So if you even have to print, then read and 100 will be printed when we'll write it to get printed. So next is encapsulation, which is one of the most important of concepts. Encapsulation means hide internal data and provide controlled access. So let us change this and let us say we have this class student and we make something private. So private is int marks. So this block is private, another we have to make public. So let's say we make two functions, set marks and get marks. So when we make set marks, it should be void because we are not returning anything, we are just setting the marks. So int m and marks is equal to m. Next thing is int get marks, and inside this we'll just return marks. Now we'll make here int main, and inside this we'll make an object of the student class, so s1. And let's say if we want to directly write s1 dot marks is 100, let's see what happens. You can see it showed us error. Why? Because here we made the marks as private, so we cannot directly change the marks of our s1 object. So for changing the marks, we have to use the set marks, which is the function that we made public. So here we'll write set marks. So when we say here that s1 dot set marks 100, then it just changed this marks and this will be set as 100 for s1 object. We can even see by printing it here. So marks, here we'll say s1 dot get marks. This is the function which we made here, which is to return marks. So you can see we got a marks 100. Successfully set our marks to be 100 using this function set marks. And get marks is to display the marks. So this is what encapsulation is. Now as we have four pillars of OOPS: encapsulation, inheritance, polymorphism, abstraction. So let us understand all of it through a simple project. So let us say that we have to find highest paid employee. Then what we have to do is first we have to make one class employee. Therein we need two variables, name and salary. That we can have a constructor to set that name and salary for every object. Then we can have a main class. Therein we can make maybe an array which contains the details, or I should say the name and salary of four employees. And then we want highest paid employee. So like we did above, we found out the maximum element in the array. We can here also we can traverse to that array and we can find the employee with the maximum salary, and after that we can print that. So let's start. First we'll make this class employee, then inside this we'll make this public string name and int salary. Then as I said, we'll can make one constructor, so string n int s, and inside this we'll say name to be set as n and salary to be s. Next is creating the main class, so int main, and inside this we will make an array employees, maybe the name of that array, and we can give maybe four elements in that array. So this will be first employee, that is because this employee is the name of the function as well as the constructor that we made. Inside this will give Rahul as 100, and although it's too less, employee, uh, and we are making another object here, so let's say Priya should get 150. Then we are making another one here, example Anu, like it will get 200, and let's say Rita here, and she'll get 120, like this. Now we want the maximum out of this, so we'll make here int max is 0, or then for int I is equal to 0, I is less than 4, I plus plus. Inside this we'll compare if employees the index I dot salary is greater than, so basically employees is this array with index I dot salary. So we are comparing these. We're not comparing the names, we're just comparing the salaries. This is greater than employees, and max index we can take here. So this is basically, we can write here max index so that it's more understandable that it's the index that having the maximum salary. And here we can change the max index to be I. We're just comparing it. If like 200 is greater than 150, then this maximum index should be 2 instead of being 1, like this. And at last we will print the highest paid employees, and inside this max index dot name, because we want to print the name of the person with the highest salary, and we can even print the salary, so salary, and here employers max index, then dot salary, then end line. So let us see. So here we got highest paid employees Anu with salary 200, and that's true. So notice how many concepts came together: classes, objects, arrays, loops, conditionals, variables. This is exactly how real software development works. Small concepts combine to create large systems. So congratulations, you have successfully completed the C++ Foundations Masterclass. Most students stop after watching videos. Don't be that student. Just practice writing these codes. Make mistakes, fix bugs. That process is what transforms beginners into programmers. In our next series, we'll begin data structures and algorithms from scratch. We'll start with arrays, strings, vectors, STL, and time complexity. If you found this masterclass useful, like the video, share it with your friends, subscribe to the channel, and comment Foundation Ready. Thank you for watching. Keep learning, keep coding, and I'll see you in the next video.